Let me start the recording. Okay, so let's join to the time. Anyways, I will go to the presentation. This week, we will be covering some of the paleoclimatic data and results from the paleoclimate. We're in the 5th week as of now. So just check it. I will present. Being recorded. Hello. Yeah. Let's wait for a few minutes and then I will start. Checking. Hello. Okay, let me just start. The recording should be there, so you can watch it later. I will try to cover the topics which are related to this week and also might be helpful to solve this assignment for this week. Let me start. So, yeah, so as this week is mostly dedicated to the paleoclimate data or determining temperatures, different compositions, or different conditions depending on that from the data, we will be dealing with different methods which can actually derive the particular instances or can recreate the conditions of those particular times. Um, so can you please confirm whether I am audible or not? Will be good to- Ankit Mukesh is there. Can you please confirm whether I am audible or not? Seems so. It is showing. Okay, fine. So there are different methods for the paleoclimate determining the events in the history. So, of course, we have well-maintained records after the discovery of different instruments. For example, after the discovery of the thermometer, we can easily determine the temperature, and we also have well-maintained record of the temperatures. For example, if we want to look at the temperature of, let's say, the year 1980 or even 1950, we can get the temperature with some good resolution. So we can almost confirmly tell that the temperature was this much at this particular region. But before the invention of the thermometer, before any measurement instruments was discovered, we had to rely or we have to rely on the evidences that are mostly obtained from nature and that the evidences which have left imprints in the nature in a protected form. If it is somehow destroyed by natural or anthropogenic causes, we cannot uh, consider it as the evidence for past climate. But if we have evidences, we can, which are also protected, we can go with that. One such evidence is of tree rings. Now, tree rings, if you look at the tree rings, you will see different, the trees have growth, especially the trees which are larger and they live for several years, let's say several hundreds of years, they grow and they, after each year, generally they leave one circle of the growth, which is known as tree ring. Now, if there are n number of tree rings, we can determine that the tree has gone through n number of years. That's why n number of rings is they are produced. So that is one evidence. Uh, Another evidence is from ice cores. Now, the case of ice core is that ice cores are generally layered. So there are different layers in the ice cores. The topmost layer, which is at the surface, let's say, will have the fresh or freshest ice, just the recent snowfall or recent ice deposition for that. But the layers which are beneath them, which are deep down, will have information for the past years, even maybe past centuries or even more than that. So ice cores exhibit important evidences for past climates. Now, if somehow we can take the ice cores and get the protected composition of the ice cores, we can get information from the ice cores, whatever was trapped in the ice core, or maybe the composition of different elements in the ice cores like that. Often, the bubbles trapped in the ice cores are studied to get the trapped air at that point of time. Let's say there is a fresh snowfall at some region, and along with the snowfall, some air is trapped. Now, it is not that all the airs will be able to pass through the ice into the atmosphere. Some air bubbles will be trapped in that ice. As years will proceed, there will be more snowfalls that will eventually become compact ice. And along with this process, there will be several layers of ice which will thicken over time. Now, from that ice cores, if we somehow can drill very deep ice, we in an unprotected, of course, it should not be unprotected, so it should be carefully investigated. Now, if we can dig that, we will get the information of the composition, let's say composition of the bubble in the ice cores. That is another important evidence. The third one is here written as ocean sediments. So similarly, in the ocean beds, there are different layers, maybe due to deposition of calcium due to living organisms or plants. There are different layers formed in the ocean base. So, and as they are layered and they are protected for very long time scale. This is one of the uh, evidences which has very old time scale. So we can also study the ocean sediments and we will get an estimation of what the composition was. And from there we can get the properties. Let's say here we are interested about the temperature at some particular time. So this was these are very famous techniques, and also there are coral reefs. From coral reefs, the coral growth is there. We can also determine from the growth, which is very similar to the growth of the tree rings, how old they were, or what information they have included into themselves. This type of things. Now, the choice of the evidence is very important. What time scale we want to look at and what property we want to look at. Now, for ocean sediments, we will get a very large range of time scale, vast range of time scale, and from ice cores also we can get that. From tree rings, we can get the data which is in the order of, let's say, 5,000 years. But for ocean sediments, the range is much larger. In the uh, I think million years ago, from million years ago, we can get the information from there. Speleothems. Speleothem is the deposition in the cave. Generally, if you look at the uh, different deep caves, there are two or several structures formed. They're known as stalagmites, stalactites, those type of things. So from there, we can also study the composition because they're also mostly the deposition of calcium or this type of sediments. So from there, we can get different layers. We can study the layers and we will get information from that cave. Now, if we want to get information about the last 5,000 years, let's say, then tree rings are very useful. If you want to get information for million year time scale, ocean sediments are useful. I think continental sediments are also there, which we can also study. And for the intermediate case, we can study ice cores. But also what are the things we are looking at is also useful. For example, if you want to study the evidence for gases, the composition of gases, then the trapped bubbles in the gases, trapped bubbles in the ice cores, that we need to study carefully. It is a very precise technique. We need to study that. But if we are interested in the temperature, we need to study the tree rings in the temperate region or in the polar region, because tree rings depend on multiple factors such as temperature, rainfall, etc., humidity. So if you are interested in temperature in the higher latitudes, then tradings are of course very good proxy. Okay.
एक्सक्यूज मी सर।
Yeah.
सर आप हमें हिंदी लैंग्वेज में पढ़ा सकते हो?
Uh, yes, please. Okay,
तो
you are.
बीच-बीच में हिंदी लैंग्वेज भी यूज़ करो सर फिर।
Oh, you are asking to teach in the Hindi language. The only problem is there are several people who will not, who might not understand Hindi. I am not very sure, but uh, if you have any particular doubt, you please just ask. I will clarify it in Hindi. I mean, if you have specific questions, but the mode of the instruction, everything is in English. So mostly for a general approach, I will be talking in English. But if you want me to answer any particular question in Hindi, I am happy to. I am not a proficient Hindi speaker, but I will try. Okay.
Okay, sir.
Please, if you
Okay,
have
thank
any questions, you just ask in Hindi. I have no problem for that. Okay.
you. Thank you, sir.
So any doubts for this slide I have shown you? Otherwise, I will go to the next slide. Okay. So just ask. So I am audible, right? You are perfectly able to hear me. I suppose so. Okay. So let me just ask you, uh, Nikita Kaushik, do you have any doubts for this one? The methods for determining the past climate data?
No, sir.
Okay, thank you. What about Priyanka Nimran? Is it fine?
Yes, sir.
Okay, thank you. Okay, okay. So here, just this slide is not directly related to the whole topic that you are studied, but just for query or completeness, I have just inserted this topic. So this shows geological timescales for the earth. So this is from very beginning. So this is for million years. Okay, million means 10 to the power 6 or 10 lakhs in our Indian system. So it is almost 4,000 million years. Uh, that is 4 billion years, or in Indian system that is 400 crore years ago. Okay, so from that point the earth was formed, and the geologists have divided the time scale into several era, aeon, period, epoch, just to uh, identify any event with easily, which event was considered happened in what era or what epoch or what period. So the current period is the current era is known as Cenozoic era. The current period is the Quaternary period, and the current epoch is known as the Holocene epoch. Before that, we studied in the lectures for this week. We studied different aspects for the Pleistocene and some aspects of the Holocene, because we have seen the ice ages, right? In this the lecture in these lectures for this week. So there were ice ages situated. We still are in the period of the ice age, but we are now in mostly ice-free domain. Some ices are limited in the northern and the south poles. Okay. So so the beginning of the Holocene happened 0.011 million years. That is, I think you can just convert it to 11,000 years ago. And the beginning of the Pleistocene, which is the Quaternary period, that happened 2.4 million years ago. So that is actually, if I just tell you, that is 24 lakh years ago. Okay. 10 to the power 6. Okay. Because million means 10 to the power 6. So you just need to multiply it by 10 to the power 6. And they are also divided into late and early. So in this Pleistocene period, early or late Pleistocene, very rapid fluctuations of temperature happened in different times. Once it was majorly covered by ice, then the extent of the ice became less. Like that, it went on. And after that, we went into a stable period of Holocene. Here, the evolution of, I mean, not evolution, but I would say the development of the human mostly happened because the Holocene epoch represents mostly stable temperature. If the temperature is stable, then we don't have to deal much with the natural condition or the natural calamity, those type of thing. Because if the natural factors are very fluctuating, then we need to rapidly cope up with that. That didn't happen for the Holocene. Those temperatures were mostly stable. That's why agriculture, civilization, these things developed a lot in this epoch of Holocene. Okay, so for this slide, any questions? All your slides will be available. I will upload that in the particular folder. Okay, so you can look at it anytime. So all this information that I am showing will be available. Okay. Any questions for this slide? Otherwise, I will proceed to the next. Okay. Ankit, Mukesh, any doubt? You can ask in Hindi also. I have no problem.
नो सर, कोई डाउट होगा तो फिर बता दूंगी सर मैं।
Sure, sure, sure. Thank you. Okay. I will proceed to the next slide. Okay. In this slide, we can just see how the proxy data are indicating the different paleoclimate indicators. So the first data we talked about was about ice layers. Okay. Now the case of the ice layer is, as we can see towards the, I will just try to zoom it a bit. So you can see here, the oldest layers will be at the bottom. The youngest layers will be at the top. It is very obvious, right? Because if snow is deposited, then it slowly be buried under different snow layers over time. So the oldest layers will be at the bottom and younger or youngest layers will be at the top. If we can somehow take a section of this ice and we can study the different parts of this layered ice, we can get an idea about the composition. Maybe there might be something trapped in the ice. There might be ice. There might be bubbles trapped in the ice also. So we can study those things from oldest layers to the youngest layers. And from there, we can determine the conditions such as the temperature or the gas composition of the earth, like that one. Okay. Similar thing goes for ocean sediments. So the bottom of the ocean sediments is solid, just the sediments which are layered structure that deposits over time. Similarly, the oldest layers will be at the bottom. They're called verbs. So, and the younger verbs will be at the top positions. Ocean sediments would provide a much larger time scale compared to the ice layers. Okay, because they are mostly undisturbed in the ocean, deep ocean. The third evidence, which is a very strong evidence, but which is not so long lasting, it is short lasting, is the about tree rings. As we discussed, the trees will produce the big trees actually, not the trees which live for only 5 or 10 years like that or less than that. There are big trees which will produce one rings on a year. So on an average. Now the growth of the rings will be determined by the temperature. Let's say the temperature is higher, then the growth of the tree rings will also be higher. So not all the tree rings will be equally spaced. The spacing will not be equal. Okay, so let's say some year, 1 year was very warm, then the growth will be also higher. 1 year was cold, then the growth will be lower. From there, we can get the information how that particular year was. Was it warm or cool? So this provides information for about, let's say, 5,000 to 8,000 years in the past. That is another good evidence, very strong evidence. But the problem is it is limited to, let's say, at most 10,000 years. Okay, that is the problem of the particular proxy. Another proxy might be for coral bands. So the younger bands will be towards the center, the oldest bands will be towards the lower region or side region, like that. So there are several coral reefs uh, across the ocean area. Okay. So these are some evidences which we try to study for paleoclimate proxy data. Okay. Doubts? Okay. Fine. So now we will discuss about a few events that occurred in the past. Now, the events are mostly studied using the proxy data. Whatever data is applicable for a particular event was used for determining that event. One such event is known as Dryas event. There are younger Dryas event, there are older Dryas event, and there are oldest Dryas events. I think this will be corrected to oldest Dryas. Okay, we will correct that. So the oldest Dryas was approximately 18,000 years to 14,000 years before present. Older was approximately 14,000 years, and that stayed for a few hundreds of years. And the original Dryas that is actually mentioned in the heading, the younger Dryas event, that was around 12,900 to 11,700 years before present. So approximately 1,200 years. It is denoted by cooling in the northern hemisphere and corresponding warming in the southern hemisphere. Now, for determining the cause, the study says that the thermohaline circulation actually weakened over this time period, causing the temperature anomaly. So there are ocean circulation which brings heat from equator to the North Pole, let's say, for this case. Now, if the thermohaline circulation is weak, then the amount of heat that will go from equator to North Pole will decrease. If the amount of heat that is transported towards the North Pole or Northern Hemisphere decreases, then of course the temperature will drop. That's why we can see cooling in the Northern Hemisphere around this time period. And corresponding heat will be the same amount of heat will be actually trapped or accumulated in the southern side of the ocean. That's why we can see warming in the southern hemisphere. That is also known as oceanic seesaw pattern. At one time northern hemisphere warms, another time southern hemisphere warms. It's like a seesaw or oscillating event. So at that Atlantic meridional overturning circulation, because it is actually studied because it is the strongest or most prominent circulation which we can relate to the temperatures of this region that determine the temperature pattern during that particular time in this time scale. So that was the cause for the temperature anomaly in the time period. Here you can see what was the temperature anomaly or what was the climatic features. What were the climatic features? So here in June to August, uh, these colors denote the temperature change compared to the present time, and the contours, or you can see the solid lines with green and brown uh, lines. These denote the amount of rainfall. So in June and August, June, July, August actually. So here the temperatures are generally should be warmer in the northern hemisphere. You can see they were slightly below normal in many of the regions in the northern hemisphere. And they were also because in June, July, August, southern hemisphere experiences the summer. So you can see the summer, especially the southeastern in the southeastern part of the Australia, close to the Antarctica. You can see very rapid warming here, high warming here. Similarly, in the December, January, February, where we experience the winter season, you can see that the temperature is abnormally lower in the northern hemisphere, especially towards the North Pole. Here also we can see higher temperature in the southern hemisphere. So overall, the northern hemisphere cooled and the southern hemisphere warmed in that time period of the younger dryas. Okay. So, and corresponding precipitation changes are also shown here. Uh, green contours show increase in the precipitation, brown contours show decrease in the precipitation. You can see they are also uh, changed over these regions. So in the summertime of the northern hemisphere, the northern part of the South America and the southern part of the North America experienced lower rainfall. But rainfall was also increased across different regions in the world. But that is not of our primary interest. We would like to focus on the temperature. So the main takeaway is that the winter temperature of the northern hemisphere and summer temperature of the southern hemisphere. Southern hemisphere had exceptionally high summer temperature during June to August, and northern hemisphere has abnormally lower temperature in the December to February. That is precisely known as the younger dryas periods. I will just go to the thermohaline circulation after that, but I would like to ask about any doubts in the younger dryas unit. So, any queries on the younger dryas unit? You can please ask.
No, sir.
Okay. Priyanka Nimra, is it fine? Okay, seems so. So I will just proceed. Now we will go to an important concept called thermohaline circulation. Thermo means heat, haline means related to salt. So thermohaline together means the circulation which is affected by both the heat difference or the temperature difference and haline, that is the salinity difference. Because you know that if we place a heavier liquid on top of a lighter liquid, then the heavier liquid will eventually go to down and the lighter liquid will come to the bottom. We will go to the top. Okay, the lighter will be at the top and the heavier will be at the bottom. Similarly, that in general, if the temperature of the liquid is high, then it will have lower density. If the temperature of the liquid is low, then it will have higher density. In case of water, if salt is dissolved in the water, then the density will be higher. If salt is not that much dissolved in the water, then the density will be lower. So this will, the two gradients, one is due to temperature, another is due to salt, will affect the circulation or they affect the circulation of the ocean throughout the world. That's why they are called thermohaline circulation. Okay. So any doubts about the thermohaline? I will of course proceed. So here we can see the pattern. What pattern? We need to study carefully. Let's say here towards the equator, the water is very warm, and due to the wind current, basically the wind current, which is also known as the trade winds, the water spontaneously, I mean, actually after being forced by the wind, it flows towards the east coast of the North America. And from there, because it is having some barrier, it will flow towards the poles, North Poles. Now, once it moves towards the poles, then the temperature of that water will be decreased. If the temperature of that water is decreased and also the salinity of the water is increased. Now, if it moves towards the North Pole, then the density will increase. If the density increases, then it will not be able to float on the top. So that water will or the circulation will shift to the bottom. And after getting some barrier here, it will move back towards the south. So Warmer or less salty water is traveling towards the North Pole, but colder and more saline water is coming from the north towards the south. Now, this will continue till the Antarctic region. After that, there is some circular pattern in this region, but that will be divided into different parts because then it has to travel somewhere. It cannot be trapped here. One part goes towards the African region from the East Africa, and this is Indian Ocean. It again warms up because the temperature of that region is high, and also due to the trade winds, it is pushed from east to west. And another part goes towards the Pacific Ocean, and it reaches the northern Pacific, and after again getting uh, the after hitting some type of boundary or getting obstructed by those areas, it travels towards the south. But as it travels from through the warmer region, eventually the water becomes blue denotes colder water and red denotes warmer water. Okay, it becomes warm, and after being warmed up and moving towards the surface, because if it is warmed up, then it will it will become lighter and it will come towards the surface. It reaches the equatorial region and it gets pushed by the trade winds, which blows from east to west. So you can see that is the boundary. Basically, it is again starting from that position because Earth is round. Now it travels across the Pacific region and again enters the Indian Ocean. Now, after entering Indian Ocean, one branch will go towards the Antarctica. Another branch will again follow the African southern tip and join this particular branch, which was again we started Atlantic meridional circulation. So the circulation that prevails over this Atlantic region is known as Atlantic Meridional Ocean Circulation, AMOC. That is very important because it transports a lot of heat from south to north, or let's say from equatorial regions to poleward regions. And that is a very important concept for determining the temperatures in this region, because if more warm water is supplied towards this region, then the regions which are closer to that point will become warmer. Somehow, if the circulation is weak, then the warm waters won't be able to reach those regions. Basically, it is distributing heat from equator to pole. So weakening of this circulation would denote cooling of this region, and strengthening of this circulation will denote warming of this region. That's why this particular Atlantic region, the circulation of the Atlantic region determines the climate of a vast portion of the world. This is connected to North America, this is connected to Europe, even this is connected to South America and African regions. So that's why the thermohaline circulation is very important, and ocean has a very high thermal inertia. That means it can transport very large amount of heat from one place to another. So somehow if this big, very enormous type of circulation is obstructed or strengthened, any change in the circulation, that will have a long lasting and widespread effect of the climate on this whole region. Okay, so that was about the thermohaline circulation. Thermo means heat, haline means salinity or salt, and both work together to drive the circulation. That's why it is known as thermohaline circulation, because it is distributing heat towards different portion of the world. It will control the climatic conditions of different portions of the world as well. And strengthening or weakening of this circulation due to some reason, we will go for explanation of one or two reasons for that. It will control the climate of these regions. Okay. Uh, any doubts on thermohaline circulation? Because that is very important. Any doubts? Priyanka Nimran?
No, sir.
Okay. Uh, Any doubts? 2255?
No, sir.
Okay, okay, thank you. Ankit, Mukesh, any doubt?
No, sir.
Okay, I will, because that is a very important concept that is even relevant for today's climate or weather conditions. And recent studies actually say that the thermohaline circulations are being uh, weakened, or they are becoming weak due to some reason. So that will have a global impact due to that. I mean, that is a very relevant topic for today's world also. There are active researches going on about studying this thermohaline circulation. That's why I just tried to bring that topic. Okay. Okay. Uh, I don't know whether I will be able to pronounce that properly. That bowling alley event. So that is another event. We were talking about mostly the events which are situated in this particular time scale, Pleistocene, and a bit of Holocene we will also cover. So most of the ice ages that we largely talk about is located in the Pleistocene era, though we are currently going through the period of ice age, just that the earth is not covered with that ice, so it is relatively uh, interstadial period where the earth is less covered with ice. But uh, if we had not intervened with the carbon dioxide or methane excretions, or insertion of those gases, then after certain time period the ices would have come. But we don't know, during considering today's climate condition or today's weather condition or human activities, when the next ice age will come. That is also matter of research. Okay. So yeah, so that is actually denoted by abrupt warming in the northern hemisphere and corresponding cooling in the southern hemisphere. So we discussed about the seesaw pattern in the thermohaline circulation. As it carries heat from the southern hemisphere to the northern hemisphere, if one warms, the other will be cooled, or there will be anti-correlation between these two regions. That's why in the Younger Dryas event, we saw cooling of the northern hemisphere but warming of the southern hemisphere. Here we see abrupt warming in the northern hemisphere and cooling in the southern hemisphere, and that occurred. That is also known as the late glacial interstadial. Interstadial means when there is less ice or less coverage of ice. Stadial means when there is more coverage of ice. So the ice age is divided into periods of stadial and interstadial events. We will also cover that. But the late glacial interstadial occurred from this time period, and that is particularly known as the polling Elrod event. So the reason for that is strengthening of the Atlantic meridional overturning circulation and weakening of the Southern Ocean overturning circulation. Now, what will happen? Let's understand from the picture. If this circulation is weak, let's say this circulation is strong, then it will carry more heat towards the northern hemisphere. You can see the red line is, I mean, the line in which I mean, the red paths are carried, that is going towards the northern hemisphere. So this will carry a lot of heat from this part or from southern hemisphere, and this uh, is from Antarctic. If this one becomes stronger and this particular circulation becomes weaker, then less heat will be trapped in the Antarctic region, but more heat will be trapped towards the northern hemisphere. That is the difference uh, for the northern and the southern parts of the globe, especially considering the Atlantic Meridional Ocean circulation. Now, last time in the Younger Dryas events, that was weak, so less heat reached the northern hemisphere, but more heat was trapped in the southern hemisphere. Now the opposite is happening, so more heat is being transported towards the northern hemisphere and less heat is trapped towards the southern hemisphere. That's why uh, we can see And this is important because it become habitable for human in this Northern American or Eurasian regions, and population increased in these areas due to favorable climate conditions. Okay, that was the small time period known as the Bowling Alley Road event. Uh, Now, both Bowling Alley Road and Younger Dryas event, they are connected with the thermohaline circulation. That's why that is the central theory based on which both of the events can be explained. We will next go to the Danskar Oiskar event, but before that, I will ask for any doubts for the Bowling Alley Road events or Younger Dryas events. Just so okay. So I will just ask you one question. So can we use the tree rings for determining this type of events? What is your idea on this from the range of the paleoclimate data, which was before 11,000 years or 12,000 years ago, before present? What can be a good proxy? Let's say I have two elements. One is tree ring, another is the ice cores. What should I choose for determining those type of events? Now, we know that the time period for determining events using the tree rings is 8,000 years, approximately 8,000 years. Before that, we won't be able to determine. Okay. So, yeah, any idea? Any input, you don't have to be worried. Just tell anything. What would you choose? Okay. Any opinion? Just choose one. Tree rings or ice core. What would you like to choose? Okay. Okay, I will just tell you that tradings won't be very effective. Nikita was trying to tell something. Yes, please.
Sir, repeat this question. I tried.
Yes, I will repeat the question. So, let's say one event has happened in the past 12,900 to 11,700 years ago. What would you choose for determining that the event happened? Would you choose tradings or would you choose the other methods for determining that events? Here, let's say ice layers, ocean sediments, or coral banks. And please give one explanation for that, whatever you choose.
Mm,
Whatever you have in mind, you can just tell. It might be true or false, nothing else.
Sir, I think true.
So you would choose tradings, right?
Yes, sir.
Okay, so I will just now tell why the tradings will not be very good for estimating that. The problem with tree rings is the oldest tree that you will get is not more than 10,000 years ago. That is the problem with the tree rings. Now you will not get any tree rings that are present since the last 10,000 years. That is the problem. Okay. Now it is before 10,000 years. It is 12,900 to 11,700. So, I mean, if there is no tree, then the tree ring will also not be there, right? So that is the,
Mhm.
so you have to choose another method. Ice core is fine, ocean sediment is fine. Uh, Anything else will work fine. But now, okay. Uh, okay, another event. Okay, let's talk about this event. Dance card Oshkar event. Let's say I I should have brought a graph here. Anyways, so rapid climate fluctuations occurred several times during the last glacial period. So in the if you go to that particular chart, the Pleistocene, that in the Pleistocene period, a large change or fluctuation in the temperature had occurred several times. Now, stadials are for colder climate when there were more ice caps or ice sheets, and interstadials for warmer climate which had less ice sheets. Now, determining that requires the data from oxygen isotope, okay, delta 18O. Now, I will ask you one simple question. The temperature fluctuations are there. I will try to also see the graph. So, uh, what is the, let's say, atomic weight of oxygen? You know, any idea about? If you don't know, you can also say that, no problem.
सर आई मतलब प्रॉब्लम हिंदी और इंग्लिश की है और कोई मतलब इशू इज इंग्लिश का इशू है सर तो
Okay,
क्वेश्चन
okay. I'm just asking you in Hindi, no problem. Oxygen का atomic number and atomic weight क्या है?
और सर
Atomic number and atomic weight of oxygen. So, okay. So, do you know about isotopes? Isotope, that word. Okay, we will. I will just cover that. No problem. Let's see. See, delta 18O means the atomic weight of oxygen 80 is 18, and it is compared to some other isotope. The general, which is most easily found or abundantly found, has the atomic weight of 60. And 18 is not that abundant, it is rarely found. But the differences in the atomic weight is it happens due to several reasons. And one of the reasons is the temperature. So if we can somehow fit that data and calibrate that, we will get the temperature in that particular region or that particular time. Now that data showed that the temperature fluctuations were there. The stadials and interstadials were clearly visible using the delta 18O data. Now the problem is from where you will get the delta 18O data, that is the question. Okay. There are methods, let's say Greenland ice cores or Antarctic ice cores from different lakes, these are there. But the takeaway is that the fluctuations occurred several times, let's say 25, I think 25 times or so within the ice age. And these fluctuations are known as the Danskard-Oeschger event. Okay. Uh, in northern hemisphere, of course, alternative rapid warming and gradual cooling. So the warming was rapid, very quick warming, and the cooling was gradual in this event. So as you actually, I explained in English. Nikita, you are the only one here. If you want any doubt, I can explain it in Hindi also. Because you are the only one here. I already explained in English.
यस सर
Hindi?
यस सर।
Okay. No, I explained it in English, so I can now
मतलब
explain.
सर इतनी डिफिकल्टी नहीं आती है ऐसे, मतलब कुछ-कुछ होता है जो मतलब समझ में नहीं आता, बिकॉज़ ऑल सिलेबस इज़ हिंदी, सो
So, may I know which study course you are pursuing now?
ये सर मेरे पास एमएससी जियोग्राफी
MSc.
हिंदी।
Okay,
यस
okay,
सर।
okay.
सर आप कोई आप ना ये मतलब जो एग्ज़ाम पैटर्न है एमसीक्यू बेस्ड है,
Right.
सो
Somehow you
एनी
can
बुक
manage.
आप बुक सजेस्ट कर सकते हो सर, कोई मतलब एमसीक्यू की?
MCQ book, huh? That is, I think, मुझे लगता है जो आप क्लास में जो पढ़ रही है, जो लेक्चर है, the questions will be mostly from that. So you don't, I mean, if you study books, then you have to study a lot. बहुत सारा पढ़ना पड़ेगा आपको. But if you just focus on the lectures, you can just get whatever is needed and whatever is required to score good. अच्छे मार्क्स लाने के लिए आप उतना पढ़ सके. ये तो मेरा सलाह है.
सर बट लेक्चर आपके रिकॉर्डेड नहीं होते हैं ना, तो समझ में नहीं आता, और आप मतलब प्रॉपर इंग्लिश, मेरा सिलेबस हिंदी में है। तो मतलब अगर कोई बुक सजेस्ट हो जाती कि एमसीक्यू की, तो एग्ज़ाम पैटर्न में हेल्प मिल जाती ना, तो इसलिए।
बट आपका एग्जाम भी तो इंग्लिश में होगी. सो
कैसा?
एग्जाम इंग्लिश में होगी, राइट?
हाँ सर, उसके लिए कोई अगर बुक हो एमसीक्यू की, वो सजेस्ट कर देते तो।
Okay. Actually, I don't know about. I will let you know if I get something. I will let you know. Maybe not today, but the next session might be. Okay. But
फिर
huh?
नेक्स्ट क्लास में बता देना आप, कोई
If I
बुक सजेस्ट।
if I get, I actually follow the lecture note and the lectures. So uh, मुझे लगता है कि लेक्चर नोट और लेक्चर पढ़ने पर हो जाएगा, बट आई डोंट नो अबाउट एनी पर्टिकुलर बुक व्हिच इज रिटन फॉर एमसीक्यू. दैट इज द प्रॉब्लम. बिकॉज ये सिलेबस जो है ये मोस्टली डिस्क्रिप्टिव टाइप है. फ्रॉम दैट वी आर ट्राइंग टू क्वेश्चन द एमसीक्यू पैटर्न. ओके.
ओके सर।
बट ओके, आई विल नाउ जस्ट एक्सप्लेन इट फॉर यू इन हिंदी, बिकॉज या यू आर द ओनली वन हियर नाउ. सो ये क्या है कि डेंसकर्ट ओएशकर इवेंट, इसमें बहुत सारा टेम्परेचर का फ्लक्चुएशन आपको दिखने को मिलेगा. तो क्या हुआ कि स्टेडियल जो था, स्टेडियल में क्या था, बर्फ और यह तापमान कम था, बर्फ का हिस्सा ज्यादा था. और जो इंटरस्टेडियल था, इन दैट पार्ट तापमान ज्यादा हो गया था और बर्फ का हिस्सा कम था. ऑफ कोर्स एज अ कंसिक्वेंस इट विल हैपन. सो गर्मी जब ज्यादा थी उसको इंटरस्टेडियल बोलते हैं. ठंडी जब सर्दी जब ज्यादा थी उसको स्टेडियल बोलते हैं. इट इज विद इन द आइसेज, आइसेज के अंदर ही ये सब हम बोल रहे हैं. एंड हाउ वी कैन गेट द डेटा, we can deal with the oxygen 18 isotope versus oxygen 16 isotope. I will explain it in detail. मैं बाद में बताऊंगा आपको कि how can we determine the temperature from that. But let's say this is the proxy data. आपके सवाल में you will have graph of oxygen 18 fluctuations delta 18 हो, उससे आपको तय करना होगा कब कब कौन हो, क्या इवेंट हुआ था, कब गर्मी ज्यादा थी, सर्दी ज्यादा थी. दिस टाइप ऑफ थिंग्स यू हैव टू डिटरमाइन. एंड ग्रीनलैंड आइस कोर्स, बिकॉज ये क्यों चुना गया, इसका कारण है कि ग्रीनलैंड हैज ऑलमोस्ट परमानेंट आइस कोर्स. सो वहाँ का जो बर्फ का जो हिस्सा, वो उसका अनुसंधान करने पर बहुत सारा चीज हमको पता चलता है कि बहुत बहुत समय से वो मौजूद है. एंड दे कैन एग्जिबिट रिलायबल एविडेंसेस. बिकॉज एविडेंसेस, व्हाट इज द क्राइटेरिया फॉर एविडेंस? एक तो शर्त है कि द एविडेंस शुड कैप्चर द इवेंट. वो जो घटना हुई है उसको सही तरीके से पकड़ पाएगी. द सेकेंड थिंग इज इट शुड बी प्रिजर्व्ड. उसको तबाह करना नहीं चाहिए. मतलब वो तबाह अगर हो जाएगा तो एविडेंस आपको नहीं मिलेगा. मतलब इट शुड नॉट बी डिस्टर्ब्ड एट एनी पॉइंट ऑफ टाइम. तो एक है इट शुड रिकॉर्ड, अच्छा रिकॉर्ड होना चाहिए. दो है कि वो वो उसका तबाह ना हो, किसी तरीके से वो नष्ट ना हो, ये देखना पड़ेगा. ओके. एंड इन नॉर्दर्न हेमिस्फीयर ऑल्टरनेटिव पीरियड्स ऑफ रैपिड वार्मिंग एंड ग्रेजुअल कूलिंग. तो जो रैपिड वार्मिंग जो हुआ था वो बहुत तेजी से हुआ था. मतलब मान लीजिए कि 100 सालों में ही तापमान काफी बढ़ गया एंड ग्रेजुअल कूलिंग, मतलब धीरे धीरे ठंड हो रही है। वो जो ग्राफ है पहले बहुत जल्दी से ऊपर जा रहा है, जल्दी से तापमान बढ़ गया, अब जब ठंडी हो रही है तो धीरे धीरे से ठंडी हो रही है। दैट इज अ टिपिकल पैटर्न। ये इसका चरित्र है ये सब घटना का। ओके, आई होप यू
ओके।
अंडरस्टैंड फाइन।
यस सर, बिल्कुल।
ओके,
आई अंडरस्टैंड।
thank you. So I will go to the next slide now. First, I have to explain in English, then I will explain in Hindi. Okay. The next thing is ice carried debris in the North Atlantic. What happened is a large group of icebergs broke from the Laurentide, or I don't know, it is called Laurentide or Laurentide. It's a Laurentide ice sheet, eventually into the North Atlantic Ocean. That is very close to the area of Canada. I mean, it is very close to Canada. That's why it easily fell into the Atlantic Ocean, North Atlantic Ocean. And what happened was the Laurentide ice sheet grew to a point such that it could not sustain its own weight. That's why it broke. It grew so big that it could not sustain its own weight, or the temperature conditions were not favorable. That's why it broke. And icebergs contain debris due to the erosion, because ice will of course cause erosion of the land. It will carry multiple items with that due to the erosion. Okay, because it will of course have some action for the ice, the weight of the ice, and they were deposited on the sea floor. Where else will it go? It has to deposit on the sea floor. Now increased delta 80 no will denote more ice. Decreased salinity, that will denote that the ice has the ocean has fresher waters. And the sedimentary composition, that will also let us know that there are something which dropped into that position. And it was first discovered by Hermann Heinrich. He was a German scientist. So these events are known as the Heinrich events, and they occurred 5 out of the last 7 glacial years over the past 66 lakh 40,000 years. Now, the icebergs have some consequences. For example, they melted after reaching the North Atlantic Ocean. Of course, it would melt, because when ice meets water, then the ice should melt. Of course, the temperature will also go down. So it will add cold and fresh water to the region. This might have altered the global thermohaline circulation, because it is driven by temperature and salinity. It is temperature cold, okay, salinity, fresh water, less saline water, causing climate fluctuation. If okay, no one else is there, so I will try to explain the. Shall I explain the same concept in Hindi?
यस सर।
I will explain the same thing in Hindi, or you understood, or shall I explain?
नो सर, आई अंडरस्टैंड।
You understood. Just for Ankit Mukesh, I just explained the ice debris in North Atlantic. Shall I explain it in Hindi for you once, or is it fine?
और मुकेश मेरी क्लासमेट है।
Okay, okay, that's fine.
ओके सर।
So shall I explain, or I will go for the next? Let me just explain it once for them, because yeah, both of you will be helpful if I just explain it.
एक्सक्यूज मी सर, आइस कैरिड ब्रिज नॉर्थ अटलांटिक, ये टॉपिक हिंदी में कवर करवा दो।
Yes, yes, actually both of you are uh, understanding Hindi, so I will just cover it. But for the recording purpose, I have to cover English. I covered the English, then now I will try to cover it in Hindi. It's okay. Uh, now क्या हुआ कि लार्ज ग्रुप ऑफ आइसबर्ग, बहुत बड़ी सी हिमशिला जो है वो टूट पड़े Lawrencide ice sheet from Lawrencide ice sheet into the North Atlantic Ocean, because ये कनाडा के बहुत करीब है. Canadian region is that region, and northern part of the America is known as the Laurentide or Laurentide area. वहां से वो टूट पड़ा नॉर्थ अटलांटिक ओशन की तरफ, बहुत नजदीक है. दैट्स व्हाई इट वेंट देयर. तो क्या हुआ कि एक समय लॉरेंटाइन आइस शीट जो था उसका ग्रोथ हुआ, वो वर्धन हुआ है, पर एक समय पर वो उसका वजन को ही सह नहीं पाया। इसके लिए एक अस्थिर अवस्था में वो पर्यवसित हुए, दैट कॉज्ड सम ऑफ इट्स पार्ट्स टू ब्रेक। तो अगर बहुत बड़े हो जाता है तो ये अपने वजन को ही सह नहीं पाएगा, ऊपर से जो बेस है, जो आइस के नीचे नीचे तरफ होगा, जो वहां वो भूमि से संयुक्त थे, वहां थोड़ा तापमान का वृद्धि भी होगी, इसके लिए वो टूट पड़ेगा। ओके, नाउ द
ओके सर।
आइसबर्ग कंटेन डेब्रिस, सो उसके साथ बहुत सारे मिट्टी बोलिए, पत्थर बोलिए, जो टुकड़ा है वो उसके साथ बह रहा था ड्यू टू इरोशन ऑफ लैंड, क्योंकि वो तो जमीन से काफी दूर बह चुका है, मतलब जमीन से गुजर चुका है, इसलिए दैट parts were contained in that thing, and the debris were deposited on the sea floor, क्योंकि उसके साथ बह रहा है वो भी तो, उसको ही तो उसको भी तो जाना ही है समुद्र के फ्लोर पे, मतलब समुद्र का जो सी बेड होता है वहां। और उसको हम कैसे पता करें? डेल्टा 18 के कंपोजिशन के द्वारा। सैलिनिटी मतलब अ, कितना नमकीन है वो समुंदर का, उससे, क्योंकि अगर बर्फ गिरता है तो सैलिनिटी घट जाएगा, क्योंकि वो उसमें बर्फ में कभी नमक नहीं होता। ओके, तो जब बर्फ गिर रहा है तो उसका सैलिनिटी घट जाएगा। तापमान भी घट जाएगा, क्योंकि बर्फ पानी से ठंडा है। वाटर इज लेट्स से 0 डिग्री सेल्सियस, बट आइस इज लेस देन 0 डिग्री सेल्सियस। ये तापमान का जो अंतर है, इसलिए। तो ये वैज्ञानिक हर्बर्ट हेनरिच ने आविष्कार किया था, इसलिए उसके नाम से इसको बोलते हैं हेनरिच इवेंट्स। और ये ड्यूरिंग 5 ऑफ द लास्ट 5 ग्लेशियल पीरियड्स, जो 7, वो जो ग्लेशियल मतलब बर्फ का जो समय, ये पर्याय को चिन्हित किया गया है, उसके 5 ऐसे समय था, 5 घटना ऐसा था जब ये टूट पड़ा, ये लॉरेंटाइन आइस शीट। ओके, ये 6,40,000 ईयर, 6,40,000 साल पहले, मतलब आज से 6,40,000 साल पहले इस समय के अंदर ये चीज हुआ है। क्या किया है ये? नॉर्थ अटलांटिक ओशन का जो सर्कुलेशन है उसको वो बिगड़ दिया। क्यों बिगड़ दिया? क्योंकि इसने ऐड किया कोल्ड और फ्रेश वाटर, ठंडा पानी ऐड किया, क्योंकि आइस ठंडा है। फ्रेश वाटर, क्योंकि आइस आइस का जो पानी है वो फ्रेश है, उसमें नमक नहीं होता। दैट्स वाई ये जो थर्मोहेलाइन सर्कुलेशन जो है, थर्मोहेलाइन मीन्स तापमान, और जो नमक है उसके उसके द्वारा जो चक्र आवर्तित होता है उसको थर्मोहेलाइन सर्कुलेशन हम पढ़े हैं, कॉजिंग क्लाइमेट फ्लक्चुएशंस। क्योंकि आपको पता है कि अगर ये चक्र का ये ताकतवर बनता है या कमजोर पड़ता है, तो उसके लिए तापमान का भी बहुत सारे जगहों में अंतर होता है। ओके,
Yes,
फाइन, ठीक है।
yes. Okay, thank you, sir.
ओके, सो आई विल कवर द नेक्स्ट topic first in English, and then if two of you are there, try to cover it in Hindi also. So last glacial maximum 20,000 years ago, uh, last glacial period when the ice sheets reached their maximum extent, and just the time is denoted between 26,000 and 20,000 years before present. And ice sheet covered a major part of course, the polar regions, or the regions with high latitudes will be covered. So Europe, North America, North Asia. Sea level dropped. Basically, if the water becomes ice, then there will be less water in the oceans, so the sea level would drop. And the global temperature was 6 degrees cooler than today. Now, if you just think about the temperature, what is the temperature in your region? Maybe 25 degrees Celsius. I will think what will happen. The temperature is 19 degrees Celsius. It will not have any effect. But if the global temperature is, average global temperature is less than 6 degrees Celsius, actually I should put the unit here, 6 degrees Celsius, cooler than today, then it would cause a massive change in different regions. Okay. And the reasons are there: orbital changes of the Earth. They are also known as Milankovitch cycles. Uh, that mainly causes the ice ages. But there are different factors also, like let's say greenhouse gases, or let's say volcanic activities. These are also there. Oh, we will cover that. Now, since 10,000 years from before present, the temperature of Earth has been very stable. It promoted agriculture, human growth, growth of civilization, this type of things. Okay, And, but recently we have experienced steady rise in temperature related to the carbon dioxide, which is completely anthropogenic. That's why we are worried about that recent increase of the temperature due to the carbon dioxide. That was the thing. Shall I cover in Hindi? Okay, because you and Nikita are there, so I will try to cover it. ओके, लास्ट क्वेश्चन मैक्सिमम, मतलब जो बर्फ का जो समय चल रहा था उससे सर्वाधिक जो बर्फ का विन्यास था या सर्वाधिक जो परिमाण था वो 20,000 साल पहले, 26,000 और 20,000 साल के पहले हुआ था। तो इस समय क्या हुआ था कि यूरोप, नॉर्थ अमेरिका और नॉर्दर्न एशिया के ज्यादातर हिस्सा आइस शीट कवर था, बर्फ के द्वारा आवृत था। और क्योंकि जल, वो पानी जम के बर्फ हो गया, उसके लिए जो समुद्र का जो तल है वो नीचे गिर गया था क्योंकि पानी ही बर्फ में रूपांतरित हो गया। जो तापमान है, धरती का जो एवरेज टेम्परेचर जो है, वो 6 डिग्री ठंडा था आज से, पर इसका बहुत बड़ा प्रभाव पड़ा था विभिन्न जगहों में। तो कुछ कुछ जगहों में तापमान और भी घट गया था, लेट से 10 डिग्री सेल्सियस और सो। तो वहाँ बहुत परिवर्तन हुआ था ये वातावरण का। इसका कारण क्या दर्शाया जाता है? ऑर्बिटल चेंजेस ऑफ द अर्थ। क्या होता है उससे? उससे जो रेडिएशन मिलता है सन से, सूरज से जो जितना शक्ति मिलता है उसका परिमाण का अंतर होता है, वो घट जाता है, बढ़ जाता है, ये चलता रहता है। तो वो अगर घट जाता है या बढ़ जाता है, थोड़ा घटने और बढ़ने से ही बहुत सारा बदलाव आ सकता है हमारे तापमान में। तो ये सूचना करता है आइस एज का। उसके बाद ये धीरे धीरे फीडबैक मैकेनिज्म्स जो है उसके द्वारा परिचालित होता है। क्या हुआ? और एक चीज हम बताना चाहते हैं, वो है कि 10,000 साल पहले से आज तक ये जो तापमान है धरती का, वो बहुत बहुत नियंत्रित रहा, हैज बीन वेरी स्टेबल। पर और इसके लिए क्या हुआ, जो हमारा जो खेती का जो बोलिए या फिर जो सभ्यता का जो विकास हुआ है वो काफी अच्छे से हो पाया है। पर दुख की बात यह है कि 1850 से आज तक तापमान बढ़ रहा है, बढ़ता ही जा रहा है। और इसका कारण हम ही हैं, हमारे द्वारा जो निश्चित CO2 गैस है, जो कार्बन डाइऑक्साइड गैस है, उसके लिए ग्रीन हाउस इफेक्ट हो रहा है, उसके लिए तापमान बढ़ रहा है। तो ये धरती का जो सामान्य रूप है, उसका खुद का जो परिवर्तन का जो हिस्सा है वो है नहीं, हम उसके अंदर अपना टांग रहे हैं, तो उसके लिए दिक्कत हुआ है। और अगर उसको अभी तक उसको सीमित ना किया जाए तो भविष्य में हमारा और भी अ, नुकसान का संभावना है। ओके, दैट इज द फाइन। ओके, okay, now I will just for interaction I would just like to ask one question. Do you know about snowball earth? Snowball earth के बारे में आपको किसी को पता है? स्नोबॉल अर्थ मीन्स धरती का पूरा हिस्सा ही बर्फ से आवृत रहेगा। कहीं पर कोई ऐसा जगह नहीं रहेगा जहां बर्फ नहीं है। इसके बारे में आप सुने हैं क्या? नहीं सुने? ओके, फाइन। सो स्नोबॉल अर्थ क्या होता था कि धरती में पूरा the earth was wholly covered by ice, and it was a stable point of equilibrium. Now from that stable, in order to reach today's position, there was vast increase of the carbon dioxide in the atmosphere. Carbon dioxide का परिमाण वो बहुत बढ़ गया था, तो उसके लिए वो that trapped additional heat and that melted some of the ice, and that uh, slowly caused the earth that is partially covered by ice. Okay, because it was a stable equilibrium. So आप तो फीडबैक के बारे में पढ़े हैं, यू हैव स्टडीड अबाउट फीडबैक्स। सो in feedback actually, uh, if ice starts growing or starts melting, that eventually reaches positive feedback. And if nothing else is there to stop it, it will either become completely snow covered or completely ice free. पूरा एक तो होगा, पूरा धरती में पूरा ही आइस रहेगा, वो एक स्टेबल इक्विलिब्रियम है, या फिर धरती में बिल्कुल भी आइस नहीं रहेगा, वो भी एक स्टेबल इक्विलिब्रियम है। तो हम जब जो समय से गुजर रहे हैं वो अनस्टेबल काइंड ऑफ सिचुएशन, तो थोड़ा आइस है थोड़ा पानी है ऐसे। Okay, let me go to the cause of the ice ages. Changes in Earth's orbit. So Earth's orbit is not completely circular, it is elliptic. So if ellipse is there, आप ellipse के बारे में पढ़े हैं? Ellipse, Nikita Kaushik, have you studied about ellipses?
No, sir.
Okay, you know about the shape of the ellipse? I think they might call, I don't know, circle which is flat. I mean, it is not a circle. If you make a circle flat, it will become ellipse, like the shape of an egg. So that is ellipse. So there is something, some parameter called eccentricity. Okay. So whether it will be a circle or it will be more compressed or less compressed will depend on the eccentricity of the ellipse. Obliquity, it is the axis of the earth, because earth is rotating, but the axis is not fixed. So the angle is 23.5 degree currently, but it changes from 20 degrees to 25 degrees, let's say like that. That is known as the obliquity. And the precision is the orientation of the axis of the earth, which might change. So let's say you have seen top rotating, right? The top rotates. If you just release the top, it will rotate, and during the rotation, it will show another kind of rotation of the axis. It is known as the precision. So these are the things due to which the amount of solar radiation or solar energy received is changed. Okay. So इससे क्या होता है कि जो सूर्य से जो शक्ति मिल रहा है, जो क्षमता मिल रहा है, उसका परिवर्तन होता है ड्यू टू द डिफरेंट ओरिएंटेशन। उसका जो दिशा होता है, अर्थ का ऑर्बिट का बोलिए या फिर ऑब्लिक्विटी, कितना कितना वो कितना एंगल से वो एक तरफ उसका एक्सिस है या फिर दूसरी तरफ उसका, इसके ऊपर ऊपर निर्भर करता है कि कितना सोलर एनर्जी उसको मिलेगा। एंड दैट हैपेंस लॉन्ग टाइम पीरियड्स, एंड these are known as Milankovitch cycle. So these are main causes. यही मुख्य कारण है आइस एज का क्यों होता है। नाउ छोटा मोटा और भी कारण है, different factors include greenhouse gases or the ocean currents we have discussed, Atlantic circulation, the Pacific circulation, thermohaline circulation, this type of thing. ये भी नियंत्रण करता है तापमान को। Okay. Another cause is the volcanic activity. अगर volcanic eruption होता है तो क्या होता है कि it can release a vast amount of carbon dioxide and it can also release aerosols. Aerosols will, if it is sulfate aerosol, it will cool the climate. If the carbon dioxide is there, आपको पता है वो तापमान को बढ़ाएगा. It will increase the temperature if the carbon dioxide is there. Now it is controlled by feedback from different processes. आपने feedback के बारे में पढ़े हैं। अगर एक forcing आता है, if there is one forcing, it is accompanied with different type of feedback mechanisms. तो क्या होता है कि एक कारण वो एक ही कारण में सीमित नहीं रहता, उसके लिए उसका अनुषंगिक बहुत सारे कारण आते जाते रहते हैं, उसके वजह से वो बहुत सारी चीजों के साथ जुड़ा रहते हैं। सपोज आपका तापमान बढ़ गया, कार्बन डाइऑक्साइड बढ़ गया, क्या होगा कि आपका जो बर्फ है वो पिघल जाएगा, उसके साथ एल्बिडो का परिवर्तन होगा, इट विल चेंज द एल्बिडो, इट विल चेंज द आइस फ्रैक्शन, ये सब बदलाव आएगा। तो क्या होगा कि इफेक्टिव एल्बिडो घट जाएगा ऐसा, या फिर बढ़ सकता है, और उसके साथ वेजिटेशन का भी चेंज होगा। ये सब चीज रेनफॉल का भी चेंज हो सकता है, अमाउंट ऑफ वाटर वेपर दैट कैन आल्सो चेंज, that can also vary. These things will be there. That's why they will cause, they will contribute to the ice ages. So there are different causes. We cannot just limit the cause of the ice age to one particular reason. Okay, but the main factor which is very strong is the Milankovitch cycle. Okay, any doubts?
No, sir.
Okay, 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 no doubt. Nikita, any doubt?
No, sir, no doubt.
Okay, thank you. Okay, so let's see. Okay, now I have a math question. So I would like with you to solve. Okay. Uh, okay, I will translate in Hindi afterwards, but I will first explain in English. Earth has currently 71% ocean and 29% continent area. There are 27 times 10 to the power 6 kilometer cube ice in the Antarctic ice sheet. How much the sea level would rise if all the Antarctic ice sheet melts? Okay, that is the question. So I will ask you. Uh, okay, just basic question. I will ask you, what will happen? क्या होगा अगर बर्फ पिघल जाए? What will happen if the ice melts? Your first impression.
Yes, sir.
हाँ, क्या होगा अगर बर्फ पिघल जाए? अंटार्कटिक आइस शीट हैज ए लॉट ऑफ आइस स्टोरेज, बहुत सारे बर्फ है वहाँ. अगर किसी कारण ग्लोबल वार्मिंग की तरह वो पिघल जाए तो क्या होगा? आपका फर्स्ट इंप्रेशन क्या है? व्हाट इज योर फर्स्ट टेक ऑन दिस?
पानी होगा, बाढ़ की समस्या हो सकती है और टेम्परेचर भी कम हो सकता है और ओशन लेवल भी तो हाई होगा सर, ओशन लेवल बढ़ जाएगा।
यस, because it is converting the ice to water, the ocean levels will increase, right?
ओके सर। हाँ
So,
सर।
हाँ, हमारा प्रश्न वही है कि हमारा इंक्रीज ओशन लेवल में कितना होगा. आपको अगर बोला जाए कि इतना बर्फ पिघलने वाला है, आपका आपको ये निकालना पड़ेगा कि ओशन लेवल कितना बढ़ेगा. ओके, यही हमारा सवाल है.
ओके सर।
So the ice has the volume 27 times 10 to the power 6 kilometer cube. Now, if that melts, how much the sea level would rise? Okay, that is the question. Now, uh, okay, for answering this, I will just ask you some simple thing. Okay, let me guide with examples. आपके पास दो कंटेनर है. ओके, आपके पास दो कंटेनर है. You have two containers and one bottle which has 1 liter of water. Okay. Now, the differences in the container is one has small base, छोटा सा container है, base छोटा है. Another has larger base. The base is very large. If you put the 1 liter water in both the containers, which would had higher level of water? इसमें पानी का स्तर कौन से में ज्यादा होगा? जो छोटा है उसमें या जो बड़ा है उसमें? That is the question. इसका जवाब दीजिए.
तो जो छोटा है उसी में होगा सर, बड़ा
Exactly.
है वो तो उसके हिसाब से फैल ही जाएगा फिर।
Right, exactly. If the container is small, because the volume is constant, right? You are just putting 1 liter of volume. So if the container is small, it will rise long, right? Till longer height. If the container is large, then it will, yeah, as you mentioned, फैल जाएगी. It will spread out. So the increase in the level will be less. Fine. So it depends on two factors. One is the surface area, another is the height. The product of the surface area times the height is the volume added, right? uh, volume, I exactly don't know what volume is called in Hindi, but the volume is basically the surface area times the height. If you consider a cone, or if you consider any shape of, if you consider a sphere, the volume is 4/3 pi r cube, like that. Okay, so volume depends on the surface area times some height, that is the volume. For Earth's case, what we will do is we will first identify the volume. Sorry, we will identify the surface area, and from there we will see how much increase it is there, because you have a fixed volume of ice. Okay. Now the surface area times the height increased will be equal to the volume given. Now the volume given here is 27 times 10 to the power 6 kilometer cube ice. And the surface area is 4 pi r square. आपको क्या पता है क्या स्फीयर का एरिया 4 pi r square है? अगर पता नहीं है तो कोई बात नहीं, आप जस्ट बोलिए. You don't know? But yeah, actually that concept is required in this problem. That's why I was asking. The area of a surface area of a sphere is 4 pi r square, where r is the radius of the sphere. That is the formula. Okay. Now, another problem is there that when the ice melts, it decreases in the volume by 9%. So if you just melt 27 times 10 to the power 6 kilometer cube of ice, it will not be 27 times 10 to the power 6 kilometer cube of ice. It will be less than that. So we have just multiplied that factor here. ऊपर से वो multiply कर दिया. नीचे से we have just put the area of the ocean. The area of the ocean is, I mean, the area is 4 pi r square, just 71% is the ocean. तो वो जो 71% है उसको हम इसके साथ multiply कर दिए. Okay. Now that rise will be evident in the kilometer. So it gives us 0.0678 kilometer, which is 67.8 meter. So roughly हमें अंदाज हो जाएगा कि कितना समुद्र का जो स्तर है वो बढ़ने वाला है. It was a very simple calculation. So जो अनुसंधानकारी है वो complicated model चलाते हैं, but it is a simple calculation. Based on that, you can see that the rise is 67.8. Now the model suggests that अनुसंधान जो किए हैं उससे पता चला कि 60 से 70 मीटर तक बढ़ सकता है. But our answer is closer to that, right? 67.8 meter. It's a simple trick to estimate the sea level rise. कोई सवाल? Any question? Please ask any question about that. Any doubts?
No, sir, no doubt.
You understood that, right?
Yes, sir, I understand.
Okay, okay. Nikita, is it fine?
Yes, sir.
Okay. Okay. If not, I will go to the next part. That is the, okay, I am just discussing about the tree ring as proxy for the temperature. I will simultaneously telling in English. So trees in mid and high latitudes generally produce one ring per year, and the widths of the rings are controlled by the temperature. तापमान ज्यादा है तो रिंग का जो वो जो क्या बढ़ना वो बढ़ना ज्यादा होगी. संख्या नहीं, just the diameter of the rings, widths of the rings. Okay, चौड़ा होगी वो. And that is applicable in the mid and high latitudes क्योंकि वहां बारिश का प्रभाव ज्यादा नहीं होता. The rainfall has less effect in these regions. Okay, and wider rings indicate more growth, ज्यादा बढ़ती है वो, caused by warmer summer temperatures. प्रधान तौर पे ये गर्मी के समय ज्यादा बढ़ता है. Okay. Now there are trees which exist since the time well before the thermometer was invented. We discussed that. हम बोले हैं कि बहुत सारे पेड़ हैं जो थर्मोमीटर का जो आविष्कार हुआ है उससे काफी पहले से ही मौजूद है. So that trees we can use for instrumentation, for instrumental data to match with the temperature and calibrate. Calibrate मतलब क्या है कि कैलिब्रेट मतलब हिंदी में मैं बोलता हूँ कि आपके पास एक टेम्परेचर डेटा है, आपके पास एक रिंग्स का डेटा है. अब आपको मिला रहा है ये रिंग्स के साथ ये टेम्परेचर जाता है, वो रिंग्स के साथ ये टेम्परेचर जाता है. दैट इज कॉल्ड कैलिब्रेशन फॉर एनीथिंग. सपोज आपके पास एक मीटर स्केल है और आपके पास एक रस्सी है, तो क्या करें, आप मीटर स्केल के साथ रस्सी में मार्क कर सकते हैं ये 1 मीटर है, ये 0.5 मीटर. दैट इज कॉल्ड कैलिब्रेशन. These in complicated terms are called calibration in models. Okay, so now this method can capture a historical data for a few thousand years, and this works well in the temperate and polar regions, but it is where the precipitation is not very high. But high precipitation जहाँ बरसात के मौसम बहुत तेज है, ज्यादा बारिश होती है, लो लैटिट्यूड्स मतलब जो निरक्ष रेखा है उसके आसपास, this method might fail because it is controlled by both temperature and rainfall. Okay. Any doubt?
नो सर।
Okay. 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 So we will just discuss a few methods for the estimation of temperature. Now, instrumental and historical data for recent years. हमारे पास जितने समय का रिकॉर्ड है अबाउट 1,000 years बिफोर टुडे, और जो इतिहास में जो लिखा गया है कुछ कुछ जगह में वो नथिभुक्त करके लिखा गया है, वो बहुत आसान तरीके से हमें मिल सकते हैं, एंड दिस इज वेरी ट्रस्टवर्दी। ओके, बहुत अच्छे से इसको हम यकीन कर सकते हैं। Tree rings with the help of models and calibration. So tree rings were existing since thousand or few thousand years, and we have the models. Model के द्वारा और calibration जो मैं बोला उसके द्वारा हम estimate कर सकते हैं. Not very good, but okay, fine. I mean, at least useful for our case. Another is the trapped air bubbles to get the composition of different gases at different times. We can also determine the composition of different isotopes. भिन्न भिन्न आइसोटोप का कितना परिमाण है वो हम तय कर सकते हैं ट्रैप्ड एयर बबल से, और एक बार वो तय हो गया उसके द्वारा हम तापमान कैसा था, उसका परिस्थिति कैसा था, वातावरण कैसा था, वो पता कर सकते हैं। फॉर गेटिंग डेटा फॉर टाइम मोर देन 1 million years ago, ओशन एंड कंटिनेंट सेडिमेंट्स आर स्टडीड। या ओशन मतलब समुद्र के जो महासागर का जो नीचे वाला हिस्सा होता है, सेडिमेंट्स, ओशन बेड जो होता है उसमें बहुत सारे सेडिमेंट्स जमा होते हैं। That sedimental layers can be studied for getting data for more than 1 million years ago. ये बहुत लंबे समय का रिकॉर्ड हमको देता है। If data from multiple sources indicate, okay, अब मैं एक सवाल पूछूंगा। Let's say you get data from multiple sources which indicate similar value. बहुत सारे जगह से आपको डेटा मिला है और वो डेटा आपको बोल रहे हैं कि ये तापमान जो है, कंपोजिशन जो है, वो एक ही तरीके का था, तो वो ज्यादा ट्रस्टवर्दी होगा, यकीन ज्यादा कर पाएंगे या यकीन कम कर पाएंगे? दैट इज द क्वेश्चन।
सर कैन यू रिपीट द क्वेश्चन?
You have got data from multiple sources and they show consistency in the values. You have got similar values from different sources. Would you trust the data more or less? That is the question.
सर मान सकते हैं कि मतलब हम विश्वास कर सकते हैं उन पर।
राइट राइट, बहुत सारी जगह से एक ही तरीके का अगर उसका मान मिला है, उसका परिमाण
हाँ
एक ही
सर।
जैसा है, तो हम बोल सकते हैं कि वहाँ का जो वातावरण था, वहाँ का जो परिस्थिति था, उसको हम बहुत सारे आंगिक से देखे हैं, और हम बोल सकते हैं कि हाँ, यकीन विश्वास कर सकते हैं कि यही स्थिति
कर
है।
सकते
We
ओके
can
सर।
trust that quite confidently.
हाँ क्योंकि वो बहुत जगह से सेम है ना सर, इसलिए।
That's yeah, that is the same logic paleoclimate scientists do. अगर बहुत सारी जगह से मिला है डेटा, so they will take it as granted. That was the condition. But the problem is there are sometimes conflicts. एक जगह देखा तापमान बढ़ रहा है, एक जगह देखा घट रहा है, then the problem comes. तब समस्या होती है।
हाँ सर, तब हम मतलब यकीन नहीं कर सकते कि ये ठीक है या नहीं है।
सही सही सही, वही वही वही, ये यही यही चुनौती है। That is the challenge for paleoclimate data.
ओके सर।
Okay, now 60. Okay, okay. I think we have reached towards the end of this session. That is the last slide. Okay. Uh, Delta 18O. I will again explain in English. And then Delta 18O is the relative difference between the sample and the standard. 18 denotes the atomic number of oxygen. 16 is also oxygen actually has three isotopes. One is 16, another is 17, and the third one is 18. So we study 18 and 16 isotopes to get the relative fraction. Okay. Now 18O is heavier than 16O. Due to this, 16O is preferred in the vapor from liquid water. So ये जो डेल्टा 18 है, इसका संज्ञा ये है कि 18/16 सैंपल डिवाइडेड बाय 18/16 स्टैंडर्ड, मतलब जो वैल्यू आज है उसका स्टैंडर्ड माना जाता है, -1 टाइम्स 1000। इसको हम पर मिल बोलते हैं। दिस इज कॉल्ड एज पर मिल, नॉट परसेंट। यू कैन सी देयर आर टू dots after this slash, not one dot. This is not percent. It is called per mil. As parts per 1,000. Okay. So two stable isotopes of oxygen. Okay. Samsthanik. I think isotopes are called like samsthanik in Hindi. I don't know properly, but okay.
ये
Okay.
स्थानिक बोलते हैं, समस्थानिक ही बोलते हैं।
Samsthanik, right? Yeah. So those samsthanik है, एक 18 है, एक 16 है. Now I will ask you another question. So 18O is little heavier than 16O. बहुत बहुत ये आसान सी चीज है कि 18 जिसका वजन है वो 16 से भारी ही होगा, because it has 18 atomic weight, it has 16 atomic weight. Okay. Now 16O is preferred in the vapor from the liquid water. Why? I will ask that question. Suppose you are given water, one is with 16O, which is light, another is with 18O, which is little heavier. So उसका जो वाष्प बनेगा, the vapor will form, which will form quickly or more easily, 16O or 18O? ये आप बताइए.
क्या सर?
Okay, just I will. There are two isotopes, 16 and 18. Now, if the vapor is formed,
ये
which one will form in an easier way, 16O or 18O? That is the question.
सर 18 ही हो सकता है, 18 को ही हम मतलब प्रेफर देंगे ना पहले तो।
Why? Why? Please give reason for that.
सर 16 तो वैसे भी मतलब 18 से छोटा ही होता है और उसमें वाटर वेपर में
16 is smaller, but 18 is,
ये
which one is heavier, 18 or 16?
18 सर।
18 is heavier. So in order to get evaporation, you have to bring that molecule from the water container to the to the evaporated state. So which is easier to bring from bottom to top, 16 or 18? जो भारी है वो आगे जाएगा या जो हल्का है वो आगे जाएगा?
सर भारी तो नीचे की तरफ आएगा ना।
Right. So which will be evaporated easier, 16 or 18? Which one?
16 सर।
16, right. So that's, and using the same logic, if you have vapor जो वाष्प है उसमें
यस
16
सर।
18 है, which will come down quickly, 16 or 18? You have vapor, it will condense into water.
18 आएगा सर नीचे
Yes.
क्योंकि वो ज्यादा भारी है।
Exactly, exactly. So that is the logic. That is the precisely the logic which we employ here to make reasons of the estimation of the temperature. 18O is preferred while water condenses into liquid, vapor condenses into liquid water, and 16 is preferred when vapor is formed from liquid water. Okay. Now, when the water moves from vapor moves from warm to cold regions, what will happen? Precipitation. वहाँ तो बारिश होता ही रहेगा because it will condense. Now, more the precipitation occurs, more 18O is separated from the water, right? वो तो अलग हो जाएगी क्योंकि जब तक precipitation चलता रहेगा 18O precipitation से अलग होता जाएगा, है ना?
यस सर।
So what will happen in the colder region, whatever vapor is there or whatever rainfall is happening in the colder region will have lower values of delta 18O, because that 18O is already separated in the warmer regions due to precipitation. आगे ही वो तो चला गया है, takes out the precipitation, takes out the 18O due to the precipitation. So जो अवशिष्ट रहेगा उसका मान कम ही होगा, है ना? Have you understood the logic?
यस सर।
क्या हुआ कि प्रेसिपिटेशन हुआ है, जब प्रेसिपिटेशन पहले पहले हो रहा तो 18O प्रेसिपिटेशन के द्वारा, बारिश के द्वारा निकल जाएगी, जो अवशिष्ट रहेगा उसमें 18O का वैल्यू कम होगा।
सर 18 का तापमान तो
तापमान
तापमान सर
तापमान नहीं, तापमान के साथ कोई रिश्ता मतलब डायरेक्टली नहीं है। सपोज आपका प्रेसिपिटेशन हो रहा है, बारिश हो रहा है, बारिश में 18O वो निकल जाएगा, 16O वेपर में रह जाएगा। अभी बारिश हुआ है वार्मर रीजन में, जब कोल्डर रीजन में वो जाएगा तब बारिश हो चुके, वो 18O निकल चुके, जो 18O बचा कुचा है उसका वैल्यू कम है, मतलब कम संख्या में 18O मॉलिक्यूल्स मौजूद है अभी। तब उसके बाद जो वहाँ प्रेसिपिटेशन होगा, वहाँ का प्रेसिपिटेशन में 18 वो कम रहेगा, क्योंकि 18 वो पहले से ही निकल जा चुका है। ओके,
ओके सर।
दैट इज द लॉजिक. Now, oceanic 18O is higher in the colder temperatures and lower in the higher temperatures, following the same logic. क्योंकि ओशन में क्या हुआ, ओशन हैज द रेनफॉल, ओशन में बारिश हुआ है, जब भी बारिश हुआ है 18O निकल चुका है, तो बारिश पे ज्यादा 18O रहेगा कंपेयर टू स्नो. ओके, क्योंकि बारिश वार्मर एनवायरनमेंट होता है, एनवायरनमेंट में होता है, और स्नोफॉल कोल्डर एनवायरनमेंट में होता है. बट फॉर गेटिंग स्नो वी नीड वेपर. In that vapor, 18O is less because it has already precipitated out in the warmer regions. Okay. Now,
ओके सर।
इसका अनुमान किया जा सकता है लाइमस्टोन के द्वारा, या फिर ट्रैप्ड एयर है उसके द्वारा भी आप कर सकते हैं, या फिर जो आइस है, आइस का कंपोजिशन को भी आप चर्चा कर सकते हैं. यू कैन स्टडी द आइस कंपोजिशन, द लाइमस्टोन, बिकॉज लाइमस्टोन हैज कैल्शियम कार्बोनेट दैट रिक्वायर्स water to form the calcium carbonate. Carbon dioxide and water forms carbonic acid which reacts with the calcium to form the calcium carbonate. So बहुत सारे तरीके हैं जिस तरीके से हम 18O का, डेल्टा 18O का अनुमान कर सकते हैं. एक बार डेल्टा 18O मिल गया तो हमें तापमान का अंदाज हो जाएगा. And if we get 80 delta 18O once, we will be able to get the temperature at that particular point and that particular region. That's how we will get the value for the delta 18O as well as the estimation of the temperature of that particular region. So if the temperature is low, then it will also tell that the delta 18O is less. Temperature is high. If the temperature is high, then it will also denote higher values of the delta 18O. क्योंकि delta 18O अगर कम है, उसका मतलब हुआ कि प्रेसिपिटेशन हो चुका है, तो जो पोलर रीजन है उसमें ज्यादा बचेगा नहीं डेल्टा 18O. अगर टेम्परेचर ज्यादा है तो पोलर रीजन में भी जो वेपर है उसमें भी डेल्टा 18O बहुत सारा बचा कुचा रहेगा. तो वो जब बारिश पैदा होगी, या बारिश क्या, जो जो बर्फबारी होगी, उसमें डेल्टा 18O का परिमाण ज्यादा होगा. इट विल बी इन हायर इन हायर लेवल्स. ओके.
ओके सर।
Okay, that was all about today's slide. Please ask for any question. कोई भी समस्या है, कोई भी जानकारी है, आप पूछ सकती हैं.
यस सर।
ओके. ओके, जस्ट आज का जो चर्चा हुआ उसके बारे में आप कोई भी सवाल पूछ सकते हैं. मैं थोड़ा इंतजार कर रहा हूँ, उसके बाद हम खत्म कर देंगे. We will just stop the meeting after a few minutes, but before that you can ask for any questions.
नो सर, नो क्वेश्चन।
Okay.
और सर वो एमसीक्यू की बुक जरूर सजेस्ट करना आप देख के नेक्स्ट क्लास में।
The problem is, I mean, yeah, I can search. दिक्कत है कि एज पार्टिकुलर एमसीक्यू ये सारे सवाल रहेगा, उसका जवाब दिया रहेगा, वो मुझे नहीं पता. मैं दो तीन बुक अगर आपको बोलूँ तो आपको बहुत ज्यादा पढ़ना पड़ेगा, यही दिक्कत है.
नहीं सर, मतलब थ्योरी वाली तो मैं मतलब मेरे पास भी है, मतलब मैं ये सोच रही थी कि एग्जाम में हेल्प मिल जाती ना, कि एमसीक्यू मैं रीड कर लेती तो उसमें हेल्प हो जाती।
कोई सैम्पल क्वेश्चन दिया जाता है, एक्चुअली मुझे एनपीटीईएल पोर्टल के एक्सेस नहीं, तो मुझे नहीं पता कि वहाँ क्या चलता है.
सर आपको तो पता होगा ना कि एग्जाम किस तरीके से होगा एंड क्या होगा।
एग्जाम आई थिंक एमसीक्यू एमसीक्यू ही होगा, या फिर शॉर्ट टाइप आंसर क्वेश्चन. असाइनमेंट जिस तरीके से है उस तरह ही होगा, मुझे ऐसा लगता है. पर्टिकुलरली मैंने एनपीटीईएल का क्वेश्चन कोर्स ऐसा किया नहीं, पर मुझे लगता है सवाल असाइनमेंट की तरह ही होगा, आसान ही रहेगा. तो मैं तो यही सलाह दूंगा कि आप पढ़िए, जो असाइनमेंट है वो सही से करिए. और सवाल, वही दिक्कत है कि ये जो सिलेबस सर कवर कर रहे हैं प्रोफेसर, इसके बेसिस में पर्टिकुलर एमसीक्यू बुक कहाँ है, वही दिक्कत है.
सर वो सर तो करवाते हैं ना, वो तो जो रिकॉर्डेड क्लास है वो तो बिल्कुल ही ऊपर से जाता है, वो तो
हाँ.
दिमाग में आता नहीं है।
ओके ओके ओके. अच्छा अच्छा.
उसके लिए तो दी हुई तो है सर बुक, वो तो कोर्स पे दी हुई है वो तो हम रीड कर लेंगे।
हाँ, मतलब उसका जो रिकॉर्डेड लेक्चर का जो बुक वर्जन है वो वाला है ना?
हाँ सर।
ओके ओके, समझ गया। असाइनमेंट का क्वेश्चन जो है, अ, वो आपको आ रहा है, सही से कर पा रही है?
सर है तो मुश्किल, वो तो ऐसे ही कर लेते हैं देख के या 2-3 कुछ करके।
ओके ओके।
असाइनमेंट वाले क्वेश्चन हम नोट कर ले क्या पेपर में उनमें से भी मतलब कुछ हो सकता है?
हाँ, आपको असाइनमेंट बहुत अच्छे से अनुसरण करना होगा, क्योंकि असाइनमेंट का जो सवाल है उस तरीके से ही आपको एग्जाम में सवाल आएंगे। हम कोशिश करते हैं कि मतलब मुझे लगता है कि असाइनमेंट का लेवल और एग्जाम का लेवल काफ़ी आसान रखा गया है या रखा जाता है। पर हाँ, दिक्कत तो वो है कि आपके पास क्वेश्चन आंसर टाइप कुछ है नहीं, तो उसके लिए दिक्कत होता है कि पूरा थ्योरी बेस्ड चीज़ अगर है तो सवाल क्या होगा उसमें, उस लिए ही असाइनमेंट बनाया जाता है। दैट इज द
हाँ,
प्रॉब्लम। तो
तो
वही।
आप सजेस्ट वैसे आप ट्राई कर लेना फिर, वरना तो ऐसे ही
हाँ,
करना पड़ेगा।
व्हाट आई डू इज, मैं जो करता हूँ कि आपको जो मैं आज का लेक्चर में बोला हूँ, दैट
हम्म,
कंसिस्ट्स ऑफ प्रीवियस ईयर्स क्वेश्चंस। ओके, तो मेरा जो मटेरियल्स है वो आपका प्रीवियस ईयर, देखिए मैं तो स्लाइड प्रदर्शन करता हूँ, उसमें छोटे छोटे चीज़ों रहता है। तो प्रीवियस ईयर का जो क्वेश्चन था, प्रीवियस ईयर का जो फोकस्ड क्वेश्चन था, उससे ही मैं बनाता हूँ, मतलब सारे क्वेश्चन ही मैं कवर कर लेता हूँ। तो आज का जो मटेरियल है उसमें प्रीवियस ईयर का सारे क्वेश्चन ही कवर्ड है, ऐसा है।
कि सर मतलब मैं क्लास पे ही अगर अच्छे से फोकस करूँ तो निकल जाएगा पेपर?
मुझे ऐसा लगता है आप अगर क्लास पे फोकस करें तो निकल जाएगी। और मेरा जो स्लाइड है उसका आपका एक्सेस है ना गूगल ड्राइव का?
यस सर।
तो उसको भी आप देख लीजिए, वहां मैं सवाल जवाब करके या जो मटेरियल से उसको एकत्रित करके रखता हूँ। क्योंकि मेरा काम है कि पिछले साल का जो सवाल है उसका सभी का आंसर, और इस वीक का हफ्ते का जो असाइनमेंट है उसका भी आंसर मैं प्रत्यक्ष रूप से नहीं दे सकता आंसर, क्योंकि वो मेरा मतलब वो सही नहीं होगा करने पर, क्योंकि वो तो एक तरीके से उत्तर जो है सवाल,
रूल के।
हाँ,
हाँ रूल नहीं है।
जवाब बोल देना है, वो नहीं कर सकता। पर वो रहता है, आप ध्यान से गौर से अगर पढ़े तो मेन पॉइंट्स कवर किया जाता है, वो जो ज़रूरत की चीज़ें वो मैं कर लेता हूँ। और पर आपको अगर कोई पर्टिकुलर मतलब विषय के अनुसार अगर कोई चीज़ आपको आप जानना चाहती है तो ज़रूर आप मुझे बोल सकते हैं, मैं कोशिश करूँगा आज ना हो तो अगले हफ्ते में जो भी टॉपिक कवर करना, या फिर कुछ नहीं समझ में आया तो वो मैं वो भी करने का कोशिश करता हूँ कि सर जो बोले उसका कुछ कुछ चीजें हाँ कर सकते हो।
ये मतलब ये जो हमने कोर्स लिया है इससे मतलब नेट के रिगार्डिंग भी कुछ ऐसे कोर्स मिल सकता है कि यहाँ से?
किसके नेट?
नेट नेशनल एलिजिबिलिटी टेस्ट।
ओके ओके, नेट का क्वेश्चन, हाँ।
यस सर।
नेट इन जियोग्राफी?
यस सर।
मैं नेट इन जियोग्राफी नहीं दिया हूँ, पर मुझे लगता है कि कुछ ना कुछ चीज तो मिलेगा ही। पैलियो क्लाइमेटिक सिचुएशन, ओशनिक सर्कुलेशन, एटमॉस्फेरिक सर्कुलेशन, ये तो मिलेगा ही आपको। नेट का मुझे लगता है आप अगर तैयारी करना चाहती है तो आप प्रीवियस ईयर्स क्वेश्चन स्टडी कीजिए, और उससे आप सेक्शन वाइज क्वेश्चन बनाइए। आप उसका पैटर्न देखिए, उसका चलन कैसा है, उसका चरित्र कैसा है वो देखिए, उसके साथ साथ आप तैयारी कीजिए।
ओके सर।
वही सबसे अच्छा
थैंक यू।
तरीका है, क्योंकि नेट का सिलेबस बहुत बड़ा होता है। कुछ कुछ जगह से ज्यादा
हाँ।
सवाल आएगी, कुछ कुछ जगह से कम। अब ये कोर्स कर रहे हैं, अगर पूरा भी पढ़ लिया शायद थोड़ा मतलब ज्यादा नहीं, कुछ ही सवाल आए ये भी हो सकता है, और ज्यादा सवाल आए ये भी हो सकता है, तो वो देखना होगा। क्या पता, जियोग्राफी में तो बहुत कुछ है, बहुत वास्ट सब्जेक्ट है।
यस। बेस बनाना ही बहुत मुश्किल है।
हाँ हाँ, सो आपको चतुरता के साथ काम निपटाना पड़ेगी।
ओके सर थैंक यू। अगर क्वेश्चन होगा तो मैं नेक्स्ट क्लास में पूछूंगा।
श्योर श्योर, आई विल question. You can also ask question. I am registered as email ID. I don't know. I'm not registered. That is the problem. But you can ask per question. Okay.
ओके सर।
You can ask in the forum stating that I want question from the coordinator at Friday's session. In that way, I can somehow raise the question. You have to just mention that, okay? If you have any.
O- Okay, sir.
Okay, thank you for joining, and thank you for your attention and cooperation today. Take care.
Thank you, sir.
Okay.
Okay, sir.